So we've seen that one way to make our interpreter lazy is simply to run the interpreter itself in a lazy language. And that works because where we have a call to interp in our interpreter, that evaluation in the lazy language will be delayed until it is actually needed, which corresponds to when this name n is used in the program that we're running. So we can do that, but that doesn't really help us understand laziness in the sense of implementing it ourselves. So another alternative is to stick with PLAI typed and delay the evaluation of arguments explicitly ourselves. So this is exactly the same code, except that I've changed interp with delay. And so delay is not going to interpret this argument expression and environment. It'll just remember them for use later. That is, delay will be the only variant of a new thunk type. It keeps the argument expression and environment together. And we'll put in our binding now, instead of putting a name and a value, we'll have a name and a thunk representing the value. When we create a delay inside the application form, then that means that when we use a name like n, when we look up something from the environment, that is when we'll force the evaluation of arg and environment. So we change the IDC case. That's the one that uses lookup to pull something out of the environment. Lookup will now give us a thunk instead of a value, and so we will use a new force helper function to force the evaluation of the thunk. Force simply takes the thunk, pulls out the argument expression and the environment, and calls interp on it to finally get that value. So if we go look at our interpreter, we see that value hasn't changed. We have a new thunk data type with the delay variant to combine an arg with an environment. Our expressions haven't changed, but our binding now has a thunk in it. If we look at interp, then we have delay here where we used to have a recursive call to interp, and we have a force around ID. Everywhere else that we have calls to interp, we don't delay those because those correspond to places where we actually need to use the value to do further work. Right? We can't produce a number plus result. We can't add them until we actually get an answer. So right now in this language, a function call and the argument to a function is the only place where we have laziness, the only place where we delay evaluation. So with that change, and we have our test case down here that checks for laziness, right here, we will see that that test case still passes, even though we're running now in PLAI typed.